Expression of concentration of solutions. There are different modes for expressing the concentration of the solutions. Okay, concentration of solution means strength of the solution. So how can we explain concentration? Concentration is the amount of solute present in the given quantity of solvent or solution. Okay, so what is mean by concentration? Concentration is the amount of solute dissolved in given quantity or given amount of solvent or solution. Okay, solvent or solution. So concentration is the amount of solute dissolved or present in given amount of solvent or solution. Okay, it can be expressed in many ways. First one is mass percent or weight percent. Mass percent or weight percent. Okay, so this means mass percent means mass of the solute present in 100 gram of the solution. Okay, mass of the solute present in 100 gram of the solution. So how can we express this as equation? Mass percent will be equal to mass of the solute by total mass of the solution into 100 gram. Okay, mass of the solute by total mass or mass of the solution into 100, this much gram. Okay, like this we can calculate the mass percent. Okay, so mass percent means mass of the solute present in 100 gram of the solution. Okay, next second one is mole fraction. Okay, mole fraction of a component in a solution is the ratio of the number of moles of that component to the number of moles of all components present in the solution. Okay, so mole fraction of a component. Mole fraction of a component in a solution is the ratio of number of moles of that component. Okay, of that component to the number of moles of all components. Okay, all components present in the solution. Okay, now suppose A represents the solute and B represents the solvent. Okay, so Na represents the number of moles of solute. Okay, and Nb represents number of moles of solvent. Okay, if A and B, A is the solute and B is the solvent, Na represents number of moles of solute and Nb represents number of moles of the solvent. Okay, and Xa is the mole fraction of solute. Okay, and Xb represents the mole fraction of solvent. So, what will be XA? XA is equal to Na by Na plus Nb. And similarly, XB equals Nb by Na plus Nb. Like this, we can express the mole fractions. Mole fraction of the solute and solvent. If more than one components are present like this, we can calculate the mole fraction of other components also. Okay, and sum of the mole fraction of all the components in a mixture. Okay, sum of the components, sum of the components of all the sum of the mole fraction, sum of the mole fraction of all components in the mixture is unity. Okay, all components in the mixture is unity. Okay, in the mixture is unity. Okay, that is, that will be equal to, if XA and XB are the mole fractions, then XA plus NB will be, XB will be equal to 1. If more than two components, then the mole fraction of all the components will be, the sum of the mole fraction of all the components will be equal to unity. Okay. Third one, molarity is denoted by capital M. Okay. So what do you mean by molarity? Is the number of moles of the solute dissolved in 1 liter of solution. Number of moles of solute dissolved in 1 liter of solution. Okay. That is, it can be expressed like this. M is equal to number of moles of solute by volume of solution in liter. Okay. Now, it can be expressed if X gram of solute is dissolved in V cubic centimeter of solution. How can you write the expression? Then M will be equal to, so number of moles is equal to the mass of the given mass of the solute by molar mass of the solute. So this will be equal to X gram of the solute by molar mass of solute into, now per liter of the solution is given V cubic centimeter. So we have to convert this into liter. So per liter V. So by V into 1000. This much molarity. Okay. There is also another expression in the case of dilution. In dilution, if we have to convert a M1 molar solution into M2 molar solution, the equation will be like this. M1V1, M1 is the molarity in the given solution with V1 volume. This will be equal to, we have to convert the solution into M2 molar into V2. How much volume we have to take on. So, if M1, V1 and M2 is given, we can calculate V2. Okay, this is the another equation we are using in the case of dilution. Okay. Fourth one, molarity expressed as small m. Molarity means number of moles of the solute per dissolved in 1 kilogram of the solvent. Okay, number of moles of solute dissolved in 1 kilogram of the solvent. Okay. So now it can be expressed like this. Small m equal number of moles of solute by mass of solvent in kilogram. Okay. Now, how can we express if x gram of solute dissolved in y gram of solvent? Okay. So we have to convert y gram into kilogram. So small m is equal to mass of the solute. Number of moles is mass by molar mass. Molar mass of solute into actually per y gram of solute. So by y into 1000. Okay, this will be the molarity because we have to convert this gram into kilogram. So into 1000 by y. Like this, small m or molarity can be calculated. Fifth one is normality, denoted by capital N. Okay. So what do I mean by normality? It is the number of gram equivalents of solute per present in 1 liter of solution. Okay. It is the number of gram equivalents of solute present in 1 liter of solution. Okay. So capital N will be equal to weight of the solute in grams. Okay. By equivalent weight of the solute. Equivalent weight of the solute into volume of the solution in liter. Okay. In liter. Now, what is the difference between equivalent weight and molar mass? Okay. Equivalent weight will be equal to molecular weight or atomic weight into molecular weight or molar mass. Molecular weight into its valency. Okay. So, in the case of molarity, we are taking molar mass or molecular weight of the solute. Here we are taking equivalent weight of the solute. So, this is the difference between these two. So, now normality can be equal to molarity into valency. This is the relation into valency. Relation between normality and molarity. Okay. Now, in dilution, there is another equation. If N1 mole of a solution can be converted into N2 moles, the equation will be N1V1 is equal to N2V2. Okay. So, N1, V1 and N2 are given. So, N2 mole we have to prepare. So, by using this equation we can calculate how much volume we have to use. That is V2 can be calculated. Okay.